All right, so now we are on to A.2, the number line and intervals. Um, so the number line can be represented by points on a line, right? So we call this the real number line. And this is actually, if you, I'm an applied mathematician, but pure mathematics, they talk about the real number line a lot. There's been a lot of mathematical studies and things to talk about it. So I usually like to draw 0 right in the middle. And it doesn't matter how you draw your numbers. You can draw them below, under, and it reads left to right, just how you would read a book. So smaller numbers like -1, -2, -3 are on the left of 0, and 1, 2, 3, and so on. Keep going. And this is actually a line segment, and then I draw my arrows and it's a line. If you remember any section, I don't know what class it would be, but like line, segment, rays. Rays only have one arrow. And that number line, those arrows mean it keeps going on forever, right? I have negative numbers, negative a billion, trillion, million, 100 million, trillion, billion, and so on. All right. So by representing the real numbers in this way, we can observe a few things. This is a lot, but it's in your book. The real numbers are dense. So what that means, if I were to close my eyes and just pick a number, I know I didn't actually close my eyes, and I just picked a point. Well, that's not on 0, not on 1, but there's still a number right there. It's probably like approximately negative 0.543, blah, 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 something like that, right? That number exists. This number exists, 2.1. There's always a number, and there's infinite amount of numbers on this line, and there's infinite amount of numbers between 0 and 1, which is crazy. There's just multiple. That would probably really hurt your heads. There's different size infinities. But that means that no matter where my pin hits on this number line, there is a number there. So what we might mean by dense, it's not just a bunch of disjoint sections. Oh, from 0 to 1, 1 to 2. I don't know how to explain. Like, what's a good analogy? It's not like railroad tracks where you just have those boards every little bit. It's like if it was just all boarded up or something, kind of like that. All right. So we also see that there's a natural ordering, 1, 2, 3, but also the negative numbers, then 0, and then all the positive numbers. We're not mixing 0, -1, 1, -2, 2, nothing like that. There's like that ordering. All right. So now we have some fun definitions. Whee! First real definition of this semester. Okay, cool. So we say that I like to highlight things. I think this day our color is green if you haven't noticed. All right, so we'll say that A is less than B, and that's how I would verbally say it. And then if I'm writing it, I would say A, that little caret, less than B. And that caret is above the comma on your keyboard. So that's how I would write it mathematically. And then I would say A is less than B. So that's what denoted means. So A is less than B, denoted A less than B, if, this is crazy, definitions for numbers is weird. B minus A is greater than 0. So geometrically, this means that A is to the left of B on the number line. That's that natural ordering of the real number line that we talked about. So it makes sense that 2 is less than 3. 3 minus 2 is 1, and that's bigger than 0. Therefore, 2 is less than 3. That's your example. And you can see that 2 is to the left of 3 on our number line. Similarly, we can say that A is greater than B. That can be denoted the other way. So A greater than B. If B minus A is, what's your guess? Less than 0. Oh, I'm writing in blue, not green. Oopsies. I'll change back. So 2 is greater than 1 since 2 minus 1. Wait. A is greater than B. 2 is greater than 1. 1 minus 2 is negative 1. Okay, that's not listed. I said it backwards in my head. All right. Okay, so A is less than B and B less than A. We define a set. There's actually a lot of debate of what a set is. Again, these mathematicians just come up with things to get paid because they're not applied mathematicians. So a set is a collection of elements. Not like an avatar. There's like 4 different elements of elements or objects, right? So I can say that the set containing only the numbers 1, 2, and 3, and 6 is denoted. Remember, denoted means how I would write this mathematically. I would call these are set brackets. Oh God, I'm really bad at drawing these. 1, comma, 2, comma, 3, comma, 6. Like that. It is, let's see if I can get type in here. Can I type in here? So I can show you what this would look like on a keyboard. That. Oh God. Can you see that? So that's a set bracket if I were to type it. I also call it a squiggly bracket. And we'll talk about brackets more because you're like, why are you calling it parentheses? Because you'll see the thing below. So that's a set bracket. That's how I would denote a finite amount of things. I know I'm throwing really big letters at you. But if I want to just talk about a few things, 1, 2, 3, 6, if I'm looking at my number line, I like to draw my number lines and graphs in this dark blue. And this is 1, 2, 3, and 6. I'm only talking about these 4 points on the number line. That's it. That's the only thing in my set. Okay, and that's when I would use set brackets. I can then talk about intervals. Intervals and sets are not even siblings, they're cousins. Okay. Mom is the number line. I don't know who that is. Less than or equal to. Oh, God. Anyways, so we talked about set brackets just now. And that now we're talking about intervals, okay? So we have closed brackets. So I also call these hard brackets or square brackets. So if I had like bracket A bracket, something like that. So an example would be like 1, 3. I could also mix them up like 1 and then 3, something like that. Denotes all numbers approaching A, including A. So that means if I'm on a number line and here's A and here's B, I would include A if I was doing like A to B. Both of those have brackets. And I would include B and then I would draw a line in between them. And we'll talk about more examples more. I'm just giving you a quick example. Right? So those are what are called closed brackets. That defines what we call a closed set. So really using like words that I learned in my analysis class, like super early on. But again, getting you used to this phrasing. And then we have open brackets. I also like to call these soft brackets or rounded brackets, just kind of like to remember the shape. And then it denotes all numbers approaching A, either to one side or the other side, depending on like this would be A, B, or like C, A, something like that. All numbers approaching A, not including A. drawing in blue again. And then if we were drawing on a number line, if we're doing like A to B again, I'm not including either of those, open circle. So the way I remember the difference between these, and especially with the dots, is closed circle. It's like a brick that has a solid outline. I know exactly where that brick ends. I don't have a brick. We're gonna use this piece of wood. So I have this piece of wood. That's why I have this. This has a solid end. Spelled wine on it, right? So I know exactly where this ends. So I call it, like, think of it like a brick. I know it ends exactly at A, ends exactly at B. I know it has a definitive border. It's closed. Soft brackets, closed, open brackets. We draw them like this little circle. I like to think it was a cloud. I don't have one of those on hand, sorry. Or like if you think this is like light orb right here, this has no definite end. I like can't tell you where the light would end or the cloud end. There's no definite border. It's just not going to be A, but it's going to be super, super, super close to A, but just not A. Okay. So let's do a few examples to like really, I'm talking theoretically, so let's do some actual things. All right. So let's talk about the set containing all numbers between 1 and 2, including 1 and 2. So you'll be asked to be like, oh, give me this in interval notation and set notation. Draw me a number line for it. All right. So didn't give myself a lot of room. Way to go, Mackenzie. So if I want to display the set of all numbers between 1 and 2, so it's all of the numbers, every single one. Am I going to use set brackets or am I going to use closed or open brackets? It's going to be these two, right? So I'm not using this because I'm doing all of the numbers. 1.5, 1.6, 1.777777777 and on, right? I can't write every single number, so I use the open and closed brackets to help me do that. Okay, so there's lots of different ways of writing this. So I can do things. I'm trying to think of the difference between if I'm including 1 and 2, including them, right? So if I include A, I use closed brackets. So it'd be 1, comma 2. This says 1 all the way up to 2, including 1 and 2. I can also say 1 less than or equal to, X is just a number, less than or equal to 2. So we use less thans here, but we also said equal to, including. Not really arbitrary. But just a number between 1 and 2, including 2. That is a really good way of representing it. And then if I wanted to draw it on a number line, bring out the blue. I'm going to draw a really long line, draw my arrows. I will usually put like 0 like off wherever side I need it to be. 1, let's space this out a little bit. 1 and 2. I'm not an artiste. So then they're closed brackets. So 1 is going to have a closed dot and 2 is going to have a closed dot. And this is telling me that I'm doing everything in between it, right? All numbers between 1 and 2. So I'm also going to fill in this line. Don't make it like a rectangle. Make sure the points on 1 and 2 are pretty clear. There's more better pictures in your textbook if my artwork isn't up to par. So, right. So that's how we would do a set like that. And then depending on the difference between including 1 and 2, that's where the open brackets would come in and those open circles. Open circle, closed circle. All right. So now let's do the set containing all numbers greater than -1. Again, there's an infinite amount. I can't fathom writing all of those. So I'm not going to use the set brackets, the squiggly brackets. I'm going to use set notation. So if I want to write all numbers greater than -1, well, I know it would be anything that satisfies x. So any x that is greater than, sorry, we don't want that line. That line means equal to. It's like combining an equal sign and a greater than sign. So x greater than -1. So it just says greater than. No including, no equal to. So that's why I'm not um, including any bar like I did here, right? These were including, so that number x could equal 2 or it could equal 1, not at the same time. So how would I draw that set? I would say, okay, we're going to call this, I would call that set notation, and I would call this interval notation. And I would just say number line. That's how I would define if I asked for set interval notation. I'll probably be like, example, that. So if I have a line under my greater than or equal to, less than or equal to, I'm going to have lines in my brackets. So close brackets. I don't have a line here, so I'm going to use open brackets. I'm not including -1. So I'm going to put -1 to the left. And what is the biggest number greater than -1? It's not actually a number. It's the idea of infinity. And negative infinity and infinity can only have open brackets. Why is that? Think about that for a second as I draw my number line. Why can't I ever have a closed bracket on infinity? I kind of mentioned it earlier. Am I recording? Oh my God, thank God. Imagine I'm just talking to myself in my kitchen at 10 p.m. on a Sunday. Wouldn't be the first time. Anyways, so these are the bad jokes I want you guys to laugh at. I can't put a closed bracket on negative infinity or infinity. Just the same reason that I said there's infinite numbers between 0 and 1, and there's infinite numbers on the number line. They're different size infinities, and I can never grasp it. It's not something that I can, because there's always infinity plus 1 or 2 times infinity. There's always bigger infinities, and it keeps growing and growing and growing. So I can never grasp negative infinity. I hope that doesn't give anyone any anxiety, because that just gave me a little bit of anxiety. Okay, cool. So now we're having -1, 0, 1, 2, and so on, right? Just all these little ticks on my number line. So now how would I write this in on the number line? Let's do a new color, let's do red. I'm not going to include -1. So I have this open circle, and then I'm just going to draw my number line. Well, Mackenzie, I can't draw the whole line. Yep, that's fine. And we just draw an arrow. Okay. You have a practice homework, which I think gives you a little bit of practice on how to work on these number lines a little bit before you do a homework and like get angry at WebAssign and then email me. So work on practice just for a little bit, because I think it'll have some stuff like this in it. Okay. So something that I didn't talk about is just kind of again another formality. It's that natural ordering of the number line that we talked about, and also kind of how I talked about how we reread left to right. How the negatives, then 0, then all the positive numbers, right? So now we always write intervals in increasing order, right? So I would write -2, comma, infinity. That's supposed to be negative infinity. So if I wrote -2 to negative infinity, that just doesn't make sense. Like, how can I read from the last chapter to the first chapter? Right, I like wouldn't say it like that, right? I read from the last page to the first page. Did you just read the back of the book? Like, it doesn't make sense, right? Like, there's no, it's a line. There's no reverse of the number line. Wow, that would be crazy. That doesn't make sense, right? It should be negative infinity. Oh my God. I do my infinities as two little circles. To -2, right? I read the first page to the last page. Okay. Is there a backside to a line? Wow, that's gonna keep me up. All right, cool. So we're on the second page now. So that's that natural ordering kicking in when we're writing intervals. And that's just when we're writing these set intervals. I'm saying interval and set and the same thing, talking about interval notation and set notation because I want you to think about like a set of like finite elements, and then I think of intervals as like on that number line, like an infinite amount of numbers. And I just lost the thought I was talking about. Oh, it is it the same? I can write -2 is greater than x, which is also greater to negative infinity. But also I can write negative infinity, right? I just need to keep my numbers, the things the same. I can switch them around. That's fine. It's really only when we write the interval notation. No, F, did I mess this up? I'm keeping it. But we write them in that increasing order. When you're writing like a set, like 1, 2, 3, 6, it doesn't matter what order you write them in. I think that's what we're talking about. Okay, good. I'm sorry about that brain confusion. Okay, cool. So next we're going to talk about combining sets and intervals. So the first combination is the intersection. I like to say words slowly so it helps me spell them out. So if I have a set named A and a set named B, and I want to take the intersection between them, I would denote that as A, and this weird looking N thing, it's not an N, it's called a cap. So A cap B is the set that consists of all elements in A and B. A cap B. That's I don't know why it's called a cap. So it's all the elements that are in A and B. So it has to be in both of them. So what's in common? They don't, sometimes we don't have anything in common. And we'll talk about that in case. All right, so then the union, this one makes a little bit more sense, of A and B is denoted that is a cup. A cup B. Sometimes also looks just like a U. U for union. It's a set that consists of all elements that are in A or B. So you think about the Venn diagram. I can just draw you a picture instead of talking with my hands. If we're talking about the Venn diagram, inside is the intersection. The whole thing is the union. Okay? Well, like we said, what if I have these two sets, A and B, and there's no overlap? What's the intersection between them? That is called the empty set. So the empty set denoted, it's a 0 with a line going through it. Is a set containing no elements. It is not the set containing the empty set. It's not the same. So it's just, if I was to say like intersection of set A and set B would just equal that. This is something different. I'll give you a warning on the first time, but if I see on the exam, I do have to take a point because it technically is incorrect. The set containing the empty set is something different because you can have sets of sets. Again, too much, I'm sorry. Okay, cool. I don't understand when people say like cap or no cap. And I get confused if it's like if something's like no cap, if that's like a good thing or a bad thing. And I just thought about it. Like A cap B. Is that saying like A is being true to B? Or just a thought. I'm a 26-year-old. Okay. So let's do some examples. So I have S is going to be the set that contains just 1, 2, 3, 4, and 5. So just those 5 numbers, not all the numbers in between them, just those 5 numbers. And then T equals 4, 5, 6, and 7. So just again, those 4 numbers. And V equals 6, 7, and 8. So if I want to find the intersection between S and T, I would look at 1, 2, you don't have to write all this, 5, squiggly bracket, intersecting with 4, 5, 6, 7. And then I would look at, okay, what numbers do I have same? Is 1 in both of them? No. Is 2 in both of them? No. 3? No. Ooh, 4. Ah, 4 is in both of them, and 5 is in both of them. Beautiful. 6 is only in 1, 7 is only in 1. So the only ones that I want are 4 and 5. Great. Now the union. Union's a lot easier. I'm going to take all the numbers that are in there. I'm just not going to repeat any. So I'm going to have 1, 2, 3, 4, and 5. That's all that's set as. But I'm not going to write 4 and 5 again. That would be weird. I've already said them. I'm not going to say their names again. So I'm just going to continue. I like checked them off in T. Yep, already said them. Roll call already. They're good to go. 6 and 7. Coolio. And that's it. I don't need to rewrite that. So union's pretty nice. You just gotta make sure you're not, when you're talking about these kind of like finite sets where you just have like 4 or 5 things in the set, when you talk about intervals, union, you sometimes can write 2 intervals. The union of them together is 1 interval, or they can still only be written as 2 intervals. We'll talk about that again. So S intersected with V. So if you want to, those numbers are kind of far away. Intersected with 6, oops, that's a 7. All right, so I want to look for things that they have in common. 1, 2, 3, 4, and 5, 6, 7, 8. There's nothing in common. So what do I put? I put a 0 and I put a line through it. Say nothing. Empty set. All right. So, and this is because there's no common elements. Okay. So now, here, you're probably writing and I'm going way too fast. We're going to talk about intersection and union of lines. So, not lines, what am I saying? It's too late. Of intervals instead of finite sets. So now A equals every number between 1 and 5, not including 1 or 5. B is 3 to 7, including only 3. And C is every number between 6 and infinity, not including 6. So I think the best way to do this is a number line. So if we go over here and draw a beautiful picture. I hope I'm not in the way. Arrow. So what's my smallest number? 1. So we'll do 1, 2, 3, 4, 5, 6. Okay, I have a lot more room. 2, 3, 4, 5, 6, 7. So let's choose some colors. So A will be green. B will be orange. And C will be this like beautiful purple. All right, cool. So A is from 1 to 5. So I'm going to draw this right here. Again, I'm just drawing my picture. Okay, cool. And then B is 3 to 7. So I'm going to draw this. And you can draw the line under if you want. Open bracket on 7. And then C is open bracket on 6. And we'll draw this one like above. I'm just drawing the lines above and below just so it's a little easier to see them all. Okay, so that's all of my number line on the same, all those sets on the same number line. Okay, excuse me. Whew. So A union B, I want to combine them, make a superset. I want, it can be in A or it can be in B. Doesn't have to be in both, it just has to be in at least one of them. So that means, so the interval 1 to 5, union 3 to 7. So I'm looking over here, that would be from 1 all the way to 7, right? So the smallest a number could be that it could be in the set is super close to 1, but not including 1. And then the biggest number that it could be is almost 7, but not including 7. So 1 and 7, right? So it's like a mashup of the two. And you can see it worked out since the left interval of one of them was smaller than the other, and then the right with the other one. Okay. Well, the intersection, so it needs to be in both of them. So if we go back and look, I now want to see where the green and the orange line up. And that happens to be on these cases. Okay. So, right, so when 1 and 5 intersect with 3 and 7. Okay. This one's a little tricky when one has a closed bracket. So look, both of these intervals contain 3, right? That one contains 3 and 3 is between 1 and 5. We can see here that that line goes through 3. So 3 is included. So both of them include 3 all the way up to B includes 5, but A does not include 5. That's what that open bracket means. So we're going to go with every number up to 5, but not including 5 because A does not contain 5 and the intersection has to be in both of the sets. Okay. So that's why we get 3 to 5, including 3. Okay. So then we want to talk about the union. Number 3 is A union C. So A again is 1 to 5, union 6 to infinity. And this is kind of what I was talking about when we write out the sets again. I can't make them smaller. 1 and 5 and 6 and 7, we would call this is not a word that you know, it's called disjoint. They don't happen at the same time. So you see this green line and this purple line, I'm pointing and you can't see. This green line right here and this purple line right here, they don't touch. So, but it's a union. So it's not going to be an empty set. It's a union. So it needs to just be in one of the sets. So just state it can be in 1 to 5 or it can be in that set. And we're done. That's it. Now I kind of gave it away. There's that intersection. Since these things do not intersect, there's no common numbers. So that would be, what is it called? The empty set. Okay. Perfect. So now we're going to talk about Just like, I don't know why they talk about it now, but what it's called, we're kind of switching away from absolute value stuff, not absolute value, set stuff to talk about the absolute value. And that's donated by these lines that are, if you're looking on your keyboard, if you ever want to type them, it's that line above like the backward slash above your like enter or return key. So it's like bar, we call those bars. So bar A bar, or just absolute value A. That's how you would say it. And it's the distance from A to the origin. Okay, this is why they put them together, talking about the number line. All right. So we can also say that if there's two possibilities, either A is greater than or equal to 0, or A is less than 0. So if A is greater than 0 and it's a positive number, and a positive absolute value, like absolute value like 2 is just 2. And so I would just spit out A. But if that number is negative, so A less than 0, then it's going to spit out the negative form of that. So in the negative of a negative is a positive. So that's why it's negative A. I want to undo that negative so that I only get a positive number out. Absolute values only give us positive numbers because distance is only in positive form, just kind of like the difference between speed and velocity. When you reverse, your odometer doesn't go into negatives. That'd be cool. All right. So it spits out the number without the negative sign. And that form right there saying that is just basically saying like negate what's already negative to only give us a positive number 9. So we'll say so it spits out A, remember A is our number, without any negative sign. So if A was -2, it would just be 2. Right? And some properties. So we kind of already talked about this, that A, absolute value of A can only give me a positive number. Sorry, I should specify and say non-negative number. 0 is not neither negative nor positive. So we say absolute value of A is greater than or equal to 0. It's equal to 0 if it is 0. And that's what we mean by the origin. I'm so sorry I didn't say that. The origin is 0. All right. So the second property, if I have two numbers multiplied by each other, so the absolute value of A times B, remember that if we just put things next to each other, we assume multiplication. That's going to be the same as I write absolute value of A times absolute value of B. I put that dot there just so it's not weird that there's two bars next to each other. Similar with multiplication, it works with the division. So the absolute value of A over B is going to be absolute value of A over absolute value of B. Okay, so now what if I have a negative? I have absolute value of negative A. What is that going to be equal to? Remember, the absolute value takes the distance between the origin. So it's going to be negative A is going to be just as far away as A is. So absolute value of A, I'm so sorry this keeps happening. Absolute value of negative A is equal to the absolute value of A. So those things were all really nice, but note that absolute value of A stops behaving nicely with addition and subtraction. So is absolute value of A plus B equal to absolute value of A plus absolute value of B? Think about 2 if A was 2 and B was -2. All right, so it doesn't, right? So if it was like -2 plus 2, well, that equals 0. It's -2 minus 2, or plus 2 is 0. And then if it was like absolute value of -2 plus absolute value of 2, well, that would just be 4. 0 is not 4. Okay. So a lot of functions don't actually behave nicely with addition, which is kind of sad. So we have already kind of said this word, but we can define distance. between A and B as the absolute value of A minus B. And sometimes we also denote this as like D A B absolute value of A minus B, right? So, and we call it like that's this, we would say this D of parentheses. In this case, we would call them of A and B equals absolute value of A minus B. So I would say in this example, D of -3 and 5 would be -3 minus 5, which is going to be -8, which is just 8. Pretty cool, right? And we can see that on the number line. -3, 2, 1, 0, 1, 2, 3, 4, 5. And if you want to count, that looks like an S. Oops. Those are 8 units apart. It's pretty cool. All right. And similar works with other numbers, right? So -5, and this is actually supposed to be -9. So -5 minus, and when it's another negative number like that, I have to put these around it. We have to distribute our negatives. So it's gonna be like -5 plus 9, which is actually just 4. So that's how a distance works between two numbers, right? You just subtract them and take the absolute value. Alrighty, so that's all that we're doing today. Done. So fun. And that's it. So I will see you guys tomorrow. If you have any questions on this, go glance through the homework, see if you can play around and kind of understand stuff more. And if you still need help, come to office hours or email me. All right. I'm so excited. That's the end of our first day.